Okay, well, hello, everyone. Let's get started, shall we? My name is Julie Dossett. I have the honor of welcoming you all here today on behalf of my colleagues here at Vector Institute. We have a terrific event for you today, and we're just so glad you could join us. I see, as the numbers tick up here, that we have people joining us from all over. Lots from here in Ontario, of course, but from communities across Canada, and a few from afar too, further far. That's great. So thank you. So all the more reason then to acknowledge the land on which I and the Vector offices are located here in Toronto. This is the traditional territory of many nations, the Mississaugas of New Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, the Wendat peoples. Toronto is covered by Treaty 13, which was signed with the Mississaugas of the New Credit, and the Williams Treaty, which was signed with multiple Mississaugas and Chippewa bands. Today, we recognize Toronto as a meeting place for many Indigenous Métis and Inuit peoples, as well as newcomers to Canada from all over the globe. We're grateful to be hosted on this land. In a moment, I'm going to hand over the virtual mic to our two guests today. But before we dive in, just a quick introduction. As I mentioned, we have people from all over. You may not know too much about Vector. Let me give you the quick description. Independent and not-for-profit, Vector Institute was established in 2017 by a group of extraordinary founders, among them Geoffrey Hinton, who I imagine will come up in conversation today. Together, these founders had a vision to drive Canada's knowledge, creation, and use of artificial intelligence, attracting the world's top faculty and researchers to collaborate on research and data and real-world problems, and to intersect with companies who are breaking new ground in the application and commercialization of AI. Above all, to help ensure all Canadians can share in the economic and social benefits and transformative potential of AI. So today, Vector is delighted to welcome our two guests, and I know that we're in for a great conversation about AI's surprisingly colorful past and equally fascinating pioneers, and of course, the themes and questions that are shaping its future here in Canada and beyond. We're going to try to cover all of that and more in about 25 minutes or so, give or take, so that we have lots of time for questions at the end from all of you. I encourage you to pop your questions in the Q&A function at the bottom of your screen, and I promise that we'll try to get to them, as many of them as we can. Also at the end, I'll have the pleasure of announcing the winners of our draw for a copy of Cade's new book. The book, that's what we're here for. Genius Makers, the Mavericks who brought AI to Google, Facebook, and the world. Officially coming out tomorrow. It's an epic story of a small group of scientists whose big ideas threw them out of the lab and into the heart of some of the world's largest companies, and in doing so, changed the world. I got to tell you, this book is rollicking. It's an insider's view of the huge and really largely untold moments that really changed everything. And along the way, though, it asks some pretty profound questions about AI and its implications for our future. Vector is proud to welcome the author of Genius Makers, Cade Metz. Hi, Cade. Cade is based in San Francisco, where he's a technology reporter with the NYTimes, covering emerging innovations from AI to robotics and virtual reality and quantum computing and all that. And previously, he was a senior staff writer with Wired magazine. Genius Makers is his first book. So congratulations, Cade. That's a big moment.
Thank you. And I'm particularly glad to be here. As I'm sure we'll discuss, Canada is a very important part of this story.
That's great. Well, we're quite grateful that you're giving us a bit of a sneak peek today. Of course, having written the book about AI pioneers and their impact, it's only fitting that Cade is joined today by yet another pioneer. Graham Taylor is an associate professor of engineering at the University of Guelph, where he leads the machine learning research group. His work in that field, along with biologically inspired computer vision, time series, and more, has earned him a wide array of honors and milestones. He is a Canada CFAR AI chair and holds a Canada Research Chair in machine learning. Graham is ideal to guide us today because he's also active in promoting the entrepreneurial activities around AI, as co-founder of Kindred AI, which has been named as one of the smartest companies in the world. Luckily for us, Graham continues to shape tomorrow's AI leaders in research, not just at Guelph, but as an academic director at NextAI, and as, let me say sincerely, a much appreciated faculty member here at Vector. Graham, thank you for joining us today. I'm so glad you could do this.
Thank you. Thanks for the assignment. It was so fun. This is amazing. I'm really excited to be here.
That's great. I'm terrific. You've all been very patient with me. So I'm actually gonna hand things right over to Graham now. Just a reminder, post those cues in the Q&A at the bottom so we can get to those in a little bit. And with no further ado, Graham, over to you.
All right. So Cade, I thoroughly enjoyed this book. And at some moments, it felt like I was back in grad school at U of T and also reliving some of the very exciting years that followed. And there are events in the book like Ilya Sutskever's moment at NeurIPS in 2014, where he says success is guaranteed. And there's also this moment where Mark Zuckerberg and Schrepp are sort of bringing these NeurIPS researchers into their hotel room in and out. And that was in 2013. And I remember these as very kind of bizarre situations, but I think it's very fitting that they were documented here. And really this moment, this zeitgeist of the mid 2010s has been captured so well. So on the other hand, though I remember some of the moments in the book, a lot of these other moments are really made me feel like I was brought in behind closed doors, and I really shouldn't have been there to see these things happening. So, some of these negotiations around the acquisitions and Jan LeCun being berated by Mark Zuckerberg. And I've never really had this experience of reading about characters that I really know, or at least I think I know so well. So you mentioned to us in the acknowledgements section of the book, it wasn't the book you were going to write. So I'd like if you could tell us a little bit more about the original idea, which you and Ethan Bassoff agreed was garbage, and really this transition from a book about tech to a book about the people of tech.
Well, it's interesting. The original book that I was going to write was in the Bitcoin area, and it had another central character, and literally I had an entire pitch ready to go to publishers. And then essentially what happened is I went to Korea for the Alphago match when DeepMind, the London lab that was acquired by Google, built this machine to play the ancient game of Go and took it to Korea to play one of the best Go players of the last decade. That was, this is covered in the book. It was an astounding moment, I think, for everyone who was there. And I still say it's one of the most amazing weeks of my life. And I wasn't even a participant. I was just a bystander. And in the wake of that, I really wanted to write a book about people like Demis Hassabis, right? One of the co-founders of DeepMind, and so many other people who I have met in covering AI. And that became the book. And that's when I met my agent, Ethan Bassoff. And he said, scrap the Bitcoin thing. You don't want to do that. You want to do this. And what really made me excited about it was this incredible cast of characters. And you've mentioned just a few, right? Ilya, I mentioned Demis. We haven't even gotten to Jeff Hinton, who's in many ways the central character. My father was an electrical engineer. He was a programmer for decades at IBM in North Carolina, where I grew up. I wanted to write a book about people like that, who are in their own incredibly fascinating and strange and unique ways, fascinating people.
So I'd like to go over to Korea in 2016, because this is a major theme in the book, and you've mentioned it already. And something I'm really inspired by, and also something I don't feel gets enough attention, is the potential for AI to influence human thinking. So midway through the book, you're describing some of the Go players who went up against DeepMind's AlphaGo and how playing the system influenced them. So there's Fan Hui, the European Go champion, who played and lost to AlphaGo kind of early on in the development. And then, of course, Lee Sedol, the Korean player who was defeated in this much watched match in 2016, and said playing the game had not only rekindled his interest in Go, it had opened his mind and given him new ideas. And he went on to win his next 9 matches against top human players. So thinking about the AI that I interact with on a daily basis, I can't say the same thing. Like, I haven't become a better or more eloquent email writer because of Gmail's Smart Compose feature. So still, this idea of AI improving human capability sounds very appealing. So have you run into more examples of people being changed through their interaction with AI?
I think that's a great question because you're showing both sides of the issue. What I can say first of all is that in Korea and through my conversations with Fan Wei, um, that was a very real phenomenon. It did change the way they saw the game of Go, and it was even more pronounced a year later when DeepMind took their system to China to play the best player in the world at that moment. Several top players were there south of Shanghai in 2017, and they had all changed the way they played based on this machine and what they had seen from this machine. So that's a real phenomenon. But at the same time, I think you're right. The question still remains, how is that going to play out in the real world, so to speak? And it shows you the difference between a game and building AI for our everyday lives. And there aren't a lot of examples of that. There are a few that you see bubbling up, right? The AI system of the moment, so to speak, which so many people in your field are talking about, is GPT-3 and these other very large language models. And I've talked to a whole lot of people who've used GPT-3 for various purposes. There's one group that's building this as kind of a creative writing tool. And so they see it in that way, right? You can have GPT-3 generate scenarios for you, right? Give it, some loose characteristics for characters in, say, a short story or a book, and spin the dice, see what it gives you, and use that as inspiration, right? That's sort of an idea. And actually, that's a pretty good use for GPT-3 because, as anyone knows, it's incredibly impressive, but it's also so flawed. And it's not going to give you something perfect every time, but it can be used as a tool like that for inspiration. There are other companies that are using reinforcement learning, as they call it, which is behind, among other things, Alphago, to model traffic patterns in large cities, to model the spread of the coronavirus. And it's not perfect, and it's not something that you're using live, so to speak, but it can be something that can help you see new ideas, see new avenues that you maybe haven't thought about. So there are possibilities there, but I think you are exactly right to say, wait, where is this in our daily lives today? And I think in a lot of ways, we're still waiting for that.
I think you've certainly pointed out a couple of key differences too in the way that we may end up engaging with AI compared to the AlphaGo situation. In the AlphaGo situation, it was this event, right? It was this monumental event that happened, whereas we might be sort of interacting on a daily basis. And the other part is AlphaGo is competitive. People played against the machine rather than working together with the machine. So the way that you're describing interacting with the GPT-3 system is more like a relationship where the AI and the human are cooperating rather than competing.
Absolutely. And again, I think that that's a distinction that has to be made between games and the real world. The gaming world is so fascinating for us humans and for a lot of reasons, but it can be misleading when we throw AI into the mix. And there were a lot of big statements made in the wake of Deep Blue, IBM's machine, beating Gary Kasparov in the 90s. I was there as well, and that's a fascinating moment. It's an important moment, but it can mislead us in a way, and we forget that our lives are not games.
Okay, so I like to go to the characters. As we mentioned before, there's many characters in this book, and I found the description of some of the personalities really quite brutal. And for example, there's Jeff's comparison of Shane Legg to Demis Hassabis when he says Shane's not as bright, not as competitive, and not as good at social interactions. He adds, but then this is almost everybody that you would compare to Demis. And that's very much in usual Jeff's style, kind of tongue in cheek. But then the description of Mark Zuckerberg, he's described as having an almost robotic demeanor, blinking his eyes unusually often, and from time to time making an unconscious clicking sound at the back of his throat, almost like he's some kind of evil robot. And then the other one I noticed, even Jan LeCun, who's quite celebrated at the beginning of the book, comes across as very cold when interacting with the media, when responding to reporters about toxic content on Facebook. So was it your intention to cast a set of heroes and villains in this story?
No, not really, to tell you the truth. All those people at other times in the book, and you mentioned this about LeCun, do things and say things that are in the book and would be lauded by so many people. Like, these are all complicated people. You talk about Zuckerberg. One of the things, the amazing thing about his story in the book is how he jumped on this idea, right? He saw this idea, among others, at Facebook at a time when, it wasn't being written about in the press, right? That's one of the things that fascinates me about the way this all played out, is that some people saw what was happening and they went after it, right? My aim with a book, any story I write at the Times, is to show people from all angles. Jan LeCun is somebody I really admire, in part because that guy is no nonsense, and he is going to tell you what you believe, what he believes. He's going to tell you what he believes, whether you're a reporter or you're a friend or you're a researcher. And anyone who has interacted with Jan LeCun over the course of their careers knows this about him, right? And that's one of the great things. And it's one of the reasons that this technology we're talking about, the idea of a neural network, actually worked, right? There were few people who really believed in it at certain points over the decades, and Jan LeCun was one of them, and he wasn't afraid to say so. Jan is not afraid to say anything, right? And in those moments where he's not afraid to say anything, you might argue that he doesn't come across, as warm and cuddly, but that is who Jan is, and I think if he was here now, he would acknowledge that. And I think a lot of people on this call who know him would acknowledge that. That said, with any story you tell, with any person you describe in a book or in a news story, there are going to be people who look at it from one angle as opposed to another, right? Everyone's going to bring their own experience and opinion to this sort of book, and I welcome that. My aim in this book is not to judge people, but to stand back and give people a picture of what has happened and let them make their own judgments.
Okay, so this book, it contains some stories about tensions that arise due to differences of ideals and incentives. So you've got researchers, companies, governments. We talked about Jan, he plays into this. We talked about Zuckerberg, he plays into this as well. Jeff is caught up in some of these tensions. And can you describe for the people who are here today, haven't read the book yet, some of these tensions that arise in the book and how you see these being played out and negotiated?
I think the prime example is Jeff Hinton. I'm sure most everyone on this call knows who he is, but for those who don't, he was born in London, studied AI at the University of Edinburgh in the early 70s, embraced this idea of a neural network when almost no one on earth embraced that idea. I mean, the idea was at its nadir in 1971 when he first embraced it in Edinburgh. He comes to the US and he finds a few people in San Diego who believe in this idea too, and he winds up at Carnegie Mellon as a professor in the computer science department in Pittsburgh in the 80s. And there's this amazing moment where he realizes that the only way to practice AI in the US is to take money from Ronald Reagan's Defense Department. And he and his wife do not want to do that. And so they leave the country. Right? And that's why he's in Toronto to this day, right? He didn't want to practice in a world where he had to take money from the US military, essentially. what's so fascinating to me are those ideals of a lot of the characters in this book. Jeff, most notably, right? He didn't want to take that DoD money, and then 20 years later, 30 years later, he's back at Google, and the same idea that he had been working on for decades is being used in a Google project in tandem with the Defense Department, right? That's the kind of clash that I'm talking about, is these very idealistic academics, for various reasons, are sucked into some of the biggest companies on earth, whose ideals might be different, right? Whose aims might be different, who are driven by the profit motive, among other things. And it's what that became the second half of the book. And it really morphed and changed, in the, 2 to 3 years after I had, sold the book to my publisher. And that becomes the real story, I think, is where those clashes happen.
I think anybody that knows Jeff is aware of this story, but it's an important story to tell. I mean, I think people outside this of Jeff's circles, people that are maybe encountering this field for the first time or picking up the book, they might not be aware of what starts not as a Canadian story, but becomes a very Canadian story, and leads to where we are now at Vector. So I get the sense that through all of this, some people who made the move from universities into corporations fared very well. Some didn't fare so well, and went through this as AI was being at least politicized and maybe to some degree weaponized. So there wasn't a lot of discussion, though, in the book about those who had given up or stepped back. So are there stories about people who walked back on this transition and just said, I want things to be like they were in 2004 and go back in time? Or did you not find that in terms of the interviews you conducted?
I mean, I think there are examples of this, right? There was so much hype in the neural network field. It creates all this hype writ large across the tech industry and AI as a whole. You see people like Neil Lawrence, who moved to Amazon. He's a British researcher in the field who was not a neural network researcher, but was one of the players that moved into industry. I visited him as I was researching the book in Cambridge. He ended up leaving Amazon and going back to academia. You see other people move out of the field for various reasons. Alex Krzyzewski, another name we haven't talked about, but probably should. He left the field for his own reasons. Just recently in the news, and I have a piece in the New York Times today about this. Timnit Gebru, has been forced out of Google because of the tensions we've been talking about. It's not in the military field; it's in the field of AI bias, and you see these examples time and again where that clash happens. Now, some people, experience that clash and they're forced out, or they want to get out. Other people stay, right? Again, it's relative how these situations are viewed. Some people think that Google working with the DoD is absolutely what should happen, right? That the U.S. needs to work with these companies, and these companies need to work with the U.S. government. So it's easy to talk about these issues as absolutes, but they're complicated. I can't tell you how complicated these issues are, and you can't necessarily judge people for staying or for leaving, right? Every situation is different.
Okay, so let's explore one more complicated issue before we go to the Q&A period, and that is the AGI debate. And I think some of the names that we've just talked about are going to come back. So throughout the book, I would say also attention in my own life has been this debate between who we might call the AGI crowd and those who recognize the real hard limits of AI technology as it exists now and would exist in the foreseeable future. And what I thought was really interesting is that you've got the usual cast of characters on the AGI side, like Elon Musk and Hassabis and Legg and Nick Bostrom. And then you've got those that are tempering the forces. So there's Jeff and Jan LeCun, who we talked about, and Ian Goodfellow and Alex Krzyzewski. But then you have this other character who is already come up today. There's Ilya Sutskever, and he makes this transition from kind of one side being, I would not say he's an AGI supporter, over the years to being quite strong and vocal on the AGI front. And as someone who went to school with Ilya and interacted with him over the years and saw this transition, I would say it's very visible. So I thought you captured this in the book really well. But something that was really surprising to me is that the story turns towards more near-term issues. So Tim Neat, who you mentioned, Meg Mitchell, the new wave of ethicists who are focused on more immediate matters like fairness and bias. And I thought at that point, the discussion around existential risks were over. Like I thought the book was done with them, but then you come back and actually conclude the book on the AGI discussion. So is this debate not done yet?
Well, it's definitely not done. And but again, I think you're asking the right question, right? This really fascinates me. You're right. There are more important issues to deal with, and the book goes into that at length, and that's where the story goes. And we do come back around to the AGI thing for two reasons. One is that, loosely speaking, the book needs to go from, it needs to be a progression through time, right? And AGI is the one that's furthest into the future, certainly. And so that's one of the reasons it ends there. But what's fascinating to me is that no matter what else happens, there is a debate over this. And I'm fascinated by the fact that I'm going to do this call today. And I know, and this starts with you, and I'm sure a lot of other people on this call, I know that a lot of people on this call are skeptical of that idea, right? And are on sort of that side of it. I'm going to do a call later this week with the University of California at Berkeley, and it's going to flip. And they are going to be on the other side, and they're going to in pointed ways say, Cade, why didn't you go further on this? Why are you playing it down the middle? This is going to happen, and it's going to happen soon. And I am fascinated by, and again, you have pinpointed the exact person. Ilya's arc in the book is unbelievable. From this moment where he interviews with DeepMind, and this is not necessarily public until the book comes out, but he interviews with DeepMind, and he just can't believe what they're talking about. Like, he just thinks they're nuts. And then, fast forward 2 to 3 years, and he's inside Google, and he sees the volume of data and the amount of processing power, and he sees, how much money, is being spent not only on technology but on talent. And his mind starts to change on this issue. And a lot of it is about who is around you. I'm always been fascinated by how ideas spread. You tend to believe what the people around you believe. And that's why that chapter, which is the second to last chapter in the book, is called Religion, right? I think the best analogy, this AGI idea is like religion, in that none of us know what the future holds. Just as none of us can really prove whether there's a God, none of us can prove whether AGI is going to arrive within the next 5 minutes, because it's in the future, right? Fundamentally, we don't know. And so you can apply almost any belief to that. And I'm fascinated by how that belief spreads between people, because that has not only happened in the past, over the past 10 years, it's happened over the past 50 years. And you see that in the book. And it is going to continue to happen. And I see this on a daily basis as I do my reporting at the Times.
I really like this aspect of the book, the fact that there's multiple time scales, and these same questions sort of play out over these different time scales and ripple throughout the book. So it's absolutely fascinating. I'm going to throw it over to Julie now, because we've got a number of questions coming in through Q&A. So we're going to turn to the audience questions now.
That's great. Thank you both. And we have a metric mid full of questions, both coming in the Q&A, and my email is just pinging away like nuts here, which is great. And it just tells me that there's clearly an appetite for these conversations and the material that you explore in the book. And of course, the question I really want to ask, which we can get to if we have time at the end, is what are all the things that didn't get in the book that you want to tell us, or what might be in the next edition. But in the meantime, let's tackle some of these, because there's some really interesting questions coming forth. People talk about AI's nuclear winter, a time when AI was ridiculed. Its researchers didn't use the term. They used robotics or language technologies and automated learning and so on. Why did this happen? Who were the players, and what caused a return to the prominence of AI?
Again, you see this pattern happen multiple times, over the course of the book, which it flashes back to the 1950s, because that's when this idea of a neural network, first took hold, right? And you get this moment in the 50s where a guy named Frank Rosenblatt, who was a University of Cornell professor who was working in a lab in Buffalo, New York, built what he called the perceptron. It's an early version of a neural network. And he gives this incredible interview with, my current employer, the New York Times. And he says some amazing stuff, right? He's built this system that can recognize printed letters on a card. So a very large printed A, right? Or a printed B. But he said that's only the beginning. The system he has built, it's going to recognize the things you say. It's going to be able to speak for itself. It's going to be able to create itself on an assembly line. It's going to fly into space and do who knows what. I have no idea. But he says all these things, and the New York Times just repeats it. And it's this moment that we then see again and again in decades to come, where the creators are so enamored of their technology and say all these things it's going to do in the future, and the press just eats it up and spits it back out. And so you get this enormous hype that's going to influence funding, right? The DoD is going to pump more money into these ideas. And then in the book, there's these great scenes between, Jeff Hinton and Marvin Minsky, among others, right? Where Minsky is really pushing back against this idea. He writes a book about perceptrons in the 60s. And then, he really takes the air out of the idea. And slowly the air falls out of AI as a whole, because there comes a point where all that hype is there, and then people realize that the hype does not match the reality, right? And that's when the funding drops out of so many projects, and you get that AI winter, which I think is a great analogy. But then the cycle starts again, right? And then by the 80s, with Jeff's backpropagation paper, which was this missing mathematical piece in neural networks, we get more hype around this, we get more progress. But then we enter another winter for this idea. And then by the early 2000s, we have another low point for the idea of a neural network, to the point where even Jan LeCun is using different terms to describe his most famous creation. It's no longer a neural network, right? That had become a nasty word in the community. It's another big idea I'm fascinated by is that cycle. It's such a cycle.
Sure, that makes sense. One of the things I was really struck, Graham pointed out that the title of a chapter is religion, and you surround yourself with the people who believe what you believe, which I think is common and has implications in a lot of different ways. And of course, sometimes with that come really strong convictions and an unwillingness to let go of what convictions that turn out to be incorrect, which of course then could feed some of that skepticism too. Then convictions are going to shape the way companies work and hire, and where science goes, where VC invests, the whole ecosystem of it. But that could really risk that we're missing out on some of the developments. Are there lessons that people either on the corporate side or in the academic research labs can take away from that? Or are there things that people are skeptical about today that you sense that we might be underestimating?
There are so many examples where this technology, as we've discussed rightly, Graham started with a question about this. It is struggling to work in so many ways, right? And yet there are already all these big problems that we can see, right? Another fascinating character in the book is Ian Goodfellow, yet another person who's not only incredibly talented, but has a great sense of humor. His most famous work, the GAN, right? These generative models that are able to create images that look like the real thing. This is another area where we really have to think about what we're doing here and where things are going. And they're not perfect yet. The worry is that we're going to get to the point where a machine can produce a realistic image, 100% of the time, a still image or video. When that happens, we're not going to be able to trust anything we see on the internet. It's going to create a situation where we really have to change the way we look at imagery as a society. I mean, that's a profound question, right? Anyone who's lived through the past 4 years, particularly in the US, but anywhere in the world, knows that this problem of disinformation is serious. And at this point, the technology is relatively simple. What happens when it gets that much better, right? So I really believe this, and this is another thread throughout the book, is that when you build technology, you really have to think about both sides of it, right? And some people are good at that, and some people are not. Some companies are good at that. Some companies are not. And it's very easy to just drive it forward without thinking about the drawbacks here. But the disinformation thing is huge, and it's just one of the huge societal questions that we're facing here.
And actually that touches on a question from someone from our audience who talks about, we see anti-science, we see anti-vaccine and anti-this and that. Is it a matter of time before we see a rise of anti-AI? And does that come from the misinformation, or does that come from concerns about, digital rights and privacy? Maybe it comes from everywhere. What can we be doing to prevent the rise of that and reassure people?
So do you mean backlash against AI in general? So people sort of saying, pushing back on researchers like so many on this call?
If I'm going to interpret this person's question, I think that's probably where that question is going. Yes. Got it.
Well, I mean, that's just part of what we need to do, right? Is push back a little bit and think about what we're doing, right? And you're seeing this in many fields. We talk about the bias question. There are people pushing on both sides of that, and there's enormous anger on both sides of that. And I see it all the time. Again, let's not think about these questions in absolute terms, that there's only one way of thinking about it. There needs to be pushback in a sense, right? And then people in the field need to listen to that and take that into account, right? It's a real balancing act, is the way I see it. And that just needs to be the case with any technology you build.
Sure.
Julie, I wouldn't mind jumping in here on this point. And I think where we may see a pushback is in all of these AI for AI solutions. And this was also in the book. So Cade mentioned these deep fakes. So, well, can we just train an AI system to find them? I mean, that was part of Facebook's solution, is to replace humans that are filtering content by algorithms. We've also heard, the problem of explainable AI systems. How do we build more explainable systems? We'll train another AI to interpret the original AI's decision. So this tends to be sort of a common response. And I think as people familiarize themselves with these systems, they might start to push back against some of this sort of automatic response. And I did feel that came out in the book.
That's a great point. The Facebook, example is the key one, right? It's very easy to say we're going to build AI that can identify hate speech and get it off our platform. Actually doing that is so much harder than people realize. And what people forget is it's hard for humans to identify hate speech, right? It can be so subtle in places. Anyone, who's been a victim of it, anyone who has not should know that. So if we humans struggle to identify hate speech, how can we build a machine that can do it, right? And when Mark Zuckerberg stands up before Congress and essentially says, we're going to solve this with AI, you absolutely have to push back against that, right? Absolutely.
You mentioned explainability as a concept, which is great. And it's actually the theme of a number of questions coming up here. And it comes up a lot around healthcare too. I think in the book you talk about an AI model around healthcare, and it was kind of, that's just a bit of a black box, which is really, a question of explainability. So how big of a hurdle is explainability for deployment? And how do we go about, persuading people around these pretty opaque ideas, I'd say, for many of the decision makers? Or is it really not that relevant as people get more comfortable with the technology?
It's a really hard question to answer, right? And fundamentally, that's where I see, a lot of the change here over the past decade is that you have systems now that learn from such enormous amounts of data, right, being deployed. And by definition, they're training on amounts of data that you and I as humans can't completely wrap our heads around, right? And so there has been this fundamental shift. And the question becomes, well, how do we deal with that? There are a lot of really interesting efforts to explain what's going on in a neural network and give us humans an idea of that. You see research coming out, every few months that pushes the ball forward. At the same time, the models are getting bigger and bigger and bigger, right? GPT-3 we talked about at the beginning of the call, right? It trains for months on data. These large language models train on so much data, it's hard for us to really get a clear picture. So, as that research pushes forward in terms of explainability, the models are getting bigger. But as you sort of hinted at, there are some people who see this differently. Like Jan LeCun is one. Like his philosophy is, you build the system and then you test it, right? And you make sure it works in its particular scenario. And if you can wrap your head around that, that's the better way to go, but that's hard too, right? These are all hard things that we're dealing with as everyday people, as researchers, as journalists, as policymakers. It's tough.
A question from one of our audience members here is interesting, kind of comes out of that a little bit and other themes. Thanks so much, Cade and Graham, enjoying the conversation. I can't wait to read the book. It's good. One striking feature of your conversation is the absence of women in the story of AI. In studying the history and the characters, what barriers did you observe to inclusivity in the field, and what can we be doing to break those down even more? I know that you have a really interesting story about Deborah Raji in the book too, and the face recognition, all that. So,
I mean, again, it's just such a great question, because this becomes a real theme in the book. Like, so many of the people we have talked about are white men, right? And that's representative of the field as a whole. And so this incredible moment, it's actually a series of moments in the book where people like Deb Raji or Joy Buolamwini at MIT, Timnit Gebru, who we talked about, Margaret Mitchell, who was at Microsoft, and then Google, they see this as a serious problem, right? Because if you're a white man, you're going to have a particular view of the world. And in building these systems, part of your job is to choose the data the systems train on. And you're going to choose data relative to your point of view. And so what you have is someone like Deb Raji, who shows up at a company called Clarify in New York City. And she's looking at the data that this company is choosing to train its content moderation system, which is a way of sort of removing pornography from social networks, or its facial recognition system. And she realizes that it's inherently biased against women and people of color, right? So it's a real issue. And so those two things are related, right? We have a problem as a society, and certainly in the tech field, of having too few women and people of color, in the field. Well, that has real consequences, right? On multiple levels, right? There are many reasons why you want a diverse workforce. And one of them is that you don't want your models to be biased. And I think this is something the industry is really struggling to deal with. And I think it's only going to get, the conflict is only going to get more important, right? With these language models like GPT-3 are in many ways the future of a company like Google. It's search engine, chat bots, so many other things. And it's not just Google, it's Microsoft and Facebook and so many others. And fundamentally, they are biased against women and people of color because they train on, enormous amounts of data from the internet, right? We all know that the internet data can be biased. We all know that there's toxic content on the internet, and that's going to come out in these systems. And it is unclear how the companies are going to solve this problem, right? They want to get the technology out. The technology is inherently biased. So what are they going to do? This is a vital question.
It's a big one. Do you think public policy plays a role in that, or really in the growth of AI generally? Maybe we stepping away from that and zooming out a bit in responsible AI. Is there a role for public policy, and what does that mean as we balance all these notions?
There is absolutely a role, right? And these companies aren't necessarily going to police themselves, and you see that in the book. You see that in the news just recently. They have other motives, right? And so on some level, they are incentivized to police themselves when it comes to this. But on another level, they're not necessarily going to do that. And so we have to think about this, as a society as a whole. And this applies not just to bias, but all these other questions we've talked about, whether it's autonomous weapons, surveillance, right? It all bleeds together. The bias question bleeds into the surveillance question, and whether or not these systems are biased, in being used by police forces or governments, right, for surveillance purposes. And so you had to think about policy not only in the U.S., not only in Canada, but in countries across the globe. And some of these become global questions, like the autonomous weapons question, right? If you ban that in the U.S., doesn't mean it's not going to happen elsewhere. So that's something you have to think about as a planet.
I have a sense Graham has things to say.
That vector also can play a role in this as well. We're in a wonderful position to do so because we can interface with policymakers, but we also can get in at the ground floor. We work directly with students, right? The 1,000 students coming into the AI master's program. So we can play a role in shaping who's coming in. We also work with universities to do hiring. So we can work to improve EDI in terms of the types of individuals we're hiring to faculty positions. So I think it's a big problem, but we're well positioned at Vector to carry the torch.
It was very smoothly done, Graham. I'm pretty impressed. It was good, but really valid too. And I think a lot about how, what are we changing about the way, that the educational process around computer science and machine learning and all the different avenues, and within that, are we talking about responsible AI and bias and privacy? One of our audience members here asked about how privacy laws like GDPR are affecting training of machine learning and developing algorithmic models, which is a whole other session, really, but really interesting too. I'm gonna switch topics a little bit. A couple of questions have come in around about computers, and we say that sometimes say that deep learning's rise was long held back by the cost of massive computation, and that graphics processing units, sometimes said to be really developed just for gaming, empowered deep learning through, by lowering the cost of some of this massive computation. To what extent do you think that's true? And how does it shed light on the future of both deep learning, but also of computer architecture?
It is absolutely true. And this is another another thing that you see in the book, right, is that, the neural network, like I said, it dates back to the 50s as an idea, and it was modified in the 80s, through a key paper by Jeff Hinton and two others. But as we use it today, it hasn't changed a whole lot. What changed is we had the data, and the internet pretty much gave us that, right? We needed large amounts of data for it to work. The other thing we needed was the processing power, right? And that arrived as well. And that's where Alex Krzyzewski comes in, right? There's this inflection point in 2012 where a neural network really starts to work with image recognition. So recognizing people and objects, cars and flowers in photos. There's this key paper from Jeff Hinton and two of his students, Ilya and Alex, that shows it can work. And a big part of that was that Alex, had some GPUs in his room at his parents' house in Toronto. And he was just really, really good at getting the most amount of power out of these GPUs. Okay. And that is what drove that result, among other things, but that is an important part of it. And that's what you see, is that even these large companies, it takes them a while to realize that is so key, right? It's, the way to get the extra processing power at this point is to use GPUs because they're suited to the type of math that drive neural networks. And so you see this other fascinating reflection in Alex's story at Google writ large when he moves there, where Google, it takes them a while, but then they say, all right, what we got to do is we got to get a whole lot of GPUs into these giant data centers that we have. And that is going to be the future of this idea. It is very real. The one thing that we're still waiting to see is there are all these companies that are building now chips that they hope will be even better at this than GPUs, that are designed specifically for machine learning. The GPU, like you said, it's a gaming processor. That's why it was built. So now there are so many efforts to build chips specifically for training a neural network. And we're not seeing that in the field that much yet. Like, there are a couple of examples, but you're not seeing a lot of that in the literature yet. It still has to mature. We still need better software to use those new chips, but that's one area where I'm going to be looking as I continue to report on this stuff to see where that goes.
So something that I find really interesting too in this conversation, but also in the book, is that you've got a story, Cade, about Jan LeCun. I think it's at Bell Labs, where he finally gets his first workstation and can get to work. And I went through this. Anybody that I think that's sort of had a career pre-2015 struggle to get computing power at some point. I remember one of my first industry jobs out of Atlanta, I couldn't get a GPU. So I went to Jeff. He opened his cupboard and pulled out an old GTX 280 card and gave it to me and said, take it to work and get going. So do you think people like Jan in this struggle to get compute benefited from that? Or Alex, having these two GPUs in his parents' house and optimizing it because he didn't have more than that. He tried so hard to sort of marry the architecture with the hardware that he had. Was that a formative experience? Vector has 11,000 GPUs now. Right. The situation is totally different. But did people kind of learn and develop from that struggle?
Well, I think they absolutely learned and developed from it, but also you really have to admire their willingness to do that, right? And their continued belief in the idea, right? And you see that in Alex, you see that in Jan LeCun. Is, to me, what it's about is you've got all these people around you who are saying this is a dumb idea, and it's not working, but then they keep working on it. And even Alex, he gets into Google, and they're just not sure, even though AlexNet as a paper is out, right? That key paper is out. Everyone knows how well it works, and yet Google still doesn't want to move to GPUs, right? Because they built this giant infrastructure on CPUs in their data centers. And Alex knows what's what. Yes, it was formative, right? Yes, it taught him a lesson, but he continues to press that lesson to others, right? And that's the real story here. And you see that, of course, with Jeff Hinton, over the decades, and even now, right? There are people pushing back. He really believes in what he's doing, and a lot of these people do, and they're willing to say, I've been there, I've seen this. You need to listen to what I'm saying, right? So I think that's a big part of it as well.
So on the topic of unstoppability, as these individuals have, it's very hard to rein this in. We have so many great questions, and each one of them is really a 15-minute discussion. I wish so much that we could all just, head down to the pub or the bar in the lobby or something to continue in person. But time does march on. So I'm going to ask you one last question, and then we're going to wrap up. And this is going to take it back home for you, really. How have you seen the discussion around AI in mainstream media evolve? So, out of the science journals into the Times and elsewhere. What used to be the hot topic and isn't anymore? What's just emerging now? And I guess the real question is, where are you seeing the big gaps in knowledge among the general public that you think are meaningful in this area?
Yeah, another great question. I struggle with this a lot, because that's one of the things I want to do with the book is show people what is real versus what is not. What I will say is that, that term artificial intelligence, I sometimes, call that the original sin of the founders of the field, that the idea that they just called it that, right? If you call something artificial intelligence, it's going to bring up all these ideas in your mind, and you're going to assume that whatever we're talking about, it can do what you can do, right? It can do what your brain can do. And that is generally not the case, right? The problem with the press is that term gets applied to everything, right? And when it gets applied, you assume that whatever it is about to happen. I think the prime example is driverless cars. Google embraced the idea of a driverless car 10 years ago. And when that happened, they put reporters in a car and they gave them a ride in a circle around Mountain View. And all the reporters got out of the car and they thought, driverless cars are here, right? They're going to be everywhere momentarily. Well, that has not happened. I don't know about you, but when I walk outside in Berkeley, California here, I'm not going to see a self-driving car. And it's a lesson that it took even reporters a long time to grasp. And I think they're slowly struggling to realize it, and have realized it on some level with self-driving cars. But we need to, apply that skepticism to all this stuff. And we need to think about what we're saying when we say artificial intelligence, because then we're passing on all that to the rest of the world. I think that's a real injustice, right? People need to understand what is real and what is not. You need to make a distinction between a self-driving car demo that goes in a circle and one that can deal with all the chaos in the world that you and I deal with as drivers. You have to make the distinction between an image recognition result, which is very powerful and very important, and AGI, right? Those are different things. And we need to kind of piece those apart a little bit better. It's a hard thing to do, but I think we need to do it.
That's terrific. Well, on the topic of real intelligence and making sense of the chaos, I think we should wrap up there, even though I feel like we're just getting started. But that's usually a pretty good sign. And I'll remind everyone that this is just a taste of what awaits you in Cade's book. You can pick up Genius Makers, The Mavericks Who Brought AI to Google, Facebook, and the world from your favorite local bookseller. There's a lot more in there. There's a bunch of questions that would talk about some of the are relevant to the stories in that book. So I do encourage everyone to pick up a copy. Last bit of good news before I thank our guests and wrap up. I'm pleased to announce 2 winners of our draw for a copy of Cade's book. They were drawn randomly from all those who registered by the deadline. Today's winners are Henna Aga and Maya Vujic. So just keep an eye out for an email from me coming your way later today. And thank you. Cade and Graham, thank you so much on behalf of everyone here at Vector and our many guests. Thank you for spending the time today and for sharing your insights. I'd like to do it again tomorrow. Congratulations, Cade, on your book. I think that we're looking forward to the next chapter of AI's story too. And to the audience, thank you very much for joining us and your great questions. Please stay safe and healthy. Most of all, go invent amazing things that will change our world. Thank you both so much.
Thank you.